All right, dividing with fractions. That's the topic we're going to talk about, but I'm actually going to save this till later. First, we'll just recap what we did yesterday with the idea of multiplicative inverses. So two numbers that have a product of 1 are called multiplicative inverses. Multiplicative inverses, or more commonly just called reciprocals. Of each other. So they multiply together to get the multiplicative identity, where anything numbered times 1 equals itself. So the reciprocal of a fraction, if it's already in fraction format, you just flip it. You switch the numerator and denominator. The reciprocal of a fraction is obtained by switching its numerator and denominator. Or as we more casually say, we flip it. We flip the fraction. But we're not always given a fraction when we're asked to find the numerator. So if it's a decimal number, or if it's a mixed number, or if it's a whole number, you would make it into an improper fraction to do so. You have to make it flippable. It's got to be flippable to find the reciprocal. So in this first example, it said 1/4 times what equals 1. So what's the multiplicative inverse of 1/4? Yes, ma'am. 4. 4, or 4/1 would also be acceptable. For the next one, if it asks us what's the multiplicative inverse, or what's the reciprocal, or what number we multiply 1 3/8 by to get 1, we would first find 1 3/8 equivalent improper fraction. So you can tell me what 1 3/8 would be as an improper fraction. Yes, sir. 11/8. So it's the same as asking, well, 11/8 times what equals 1? Once we know that 1 3/8 is equivalent to 11/8, we flip it. And 1 3/8 reciprocal is what? Yes, sir. 8/11. And now we're going to go ahead and start finding out that it's useful for division. So when you're dealing with word problems, you need to know when to use division. So now we're going back up to the top here. You use division when splitting up an amount of an item to find how many parts can be made or how much will be in each part. So you go, oh, I have this ribbon, and for every bow I need to use 2 3/4 of an inch. So you're going to take the entire length of the ribbon, let's say it's 3 feet, so therefore 36 inches. 36 divided by the 2 3/4. Or you could say, I have this 3 feet of ribbon, and I want to get, it's so pretty, I want to give it to my friends. So I want to give it to 5 different friends. How much would each of them get? So that, well, okay, that would work out. You wouldn't have 2 1/2 friends. Anyway, so you would do 36 divided by 5, and that wouldn't need fractions. But you get the idea of how the two different scenarios play out. You either have a certain total amount, and you're trying to see how many you can get of a certain size, or you have a certain amount, and you're saying, I want to make a certain amount of groups. I want to separate it out. So now if we have a fraction involved, this is where we have to use our reciprocal. To divide a number by a fraction, multiply the first number by the reciprocal of the fraction. So remember to leave the first number alone and flip the second number only. Don't go flipping crazy and flip them both. Nor do you want to flip the first one only. So the first one always stays the same, and you flip it the second one. Also, because we're going to then change it to a multiplication problem, so it says multiply the first number by the reciprocal of the second, check if you can simplify before you multiply. But you can't do that step until you're at the step where you have a multiplication problem. So for these examples, the thing we really want to highlight and note is that we don't want to just rewrite over the original problem. We want to show the steps to get to our solution. So 3/4 divided by 1/6. Who thinks they know what equivalent multiplication problem we could use? 3/4 divided by 1/6. Instead we could do what?
3/4 times 6.
3/4 times 6, or because it's going to be multiplication involving fractions, 6/1 is going to be our preferred reciprocal in this case. Now, a lot of people accidentally, when they're starting out with the 3/4 divided by 1/6, will get all giddy and go, ooh, 3 and 6, I can simplify those. Do not try to simplify until you've turned it into a multiplication problem. Now we turn it into a multiplication problem. So is there anything we can simplify before we multiply? Yes, sir.
The 4 can become a 2 because you're dividing it by 2, and then 6 can become.
Mm-hmm. Now, if you, like me, were giddy thinking 3 and 6, yay, that's, my mind sees it, woo, and then I go, oh wait, not ready for that. So then you flip it and you realize, oh, the 3 and 6 are now both on top, I can't simplify those. So maybe you were so bummed about that you didn't realize you can simplify a 2 out of the 6 and 4. It's okay. You would have just got 18/4, and then you would have simplified it later. So as long as you simplify it at some point before you give a final answer. But usually our life's a little easier if we simplify before we multiply. So now we have an equivalent multiplication expression of 3 times 3 over 2 times 1, which equals what? Yes, sir.
9/2.
9/2, 9 over 2. But that's not proper. What would be our proper answer? Yes, ma'am.
4
4
1/2.
1/2. So what we basically just found is that there are 4 1/2 sixths in 3/4. Now for the next one. 4/5 divided by 2/3. Who can tell me what equivalent multiplication expression I could do? Yes, ma'am.
4/5 times is
4/5 times 3 over 2. 4/5 times 3/2. Is there anything I can simplify before I multiply? Sometimes there is, sometimes there isn't. Yes, sir?
You can simplify the 4 to a 2 and the 2 and the other 2 as the denominator to a 1.
Mm-hmm. I can divide a 2 out of the 4 and a 2 out of the 2. So make it 2 times 3 over 5 times 1. What do I get when I multiply that out? Yes, ma'am.
6/5.
6/5. And that's not proper. So what would be our final proper answer for this problem? 1 1/5. So this is saying if I had 4/5 of something and I wanted to divvy it up into 2/3 sections that are 2/3 each, I could make 1 1/5 of that size, 2/3. For the next part, we have to deal with what if there are mixed numbers or whole numbers in our problems. So this is where we're going to end up with a 5-step process. And only 2 of the steps use real words. So the longer explanation, to divide with whole numbers or mixed numbers, convert to improper fractions. Then multiply the dividend by the reciprocal of the divisor. After simplifying. You want to make sure you multiply after you simplify if possible. So here's our 5-step process. I'm going to write it over to the side here. We are going to improperify. Not a real word, but it helps me remember. I got to make improper fractions. Then we are going to flipify. When we flipify, we're making it into a multiplication problem. Again, not a real word, but it reminds me. Then we're going to simplify, not until after we've made it into a multiplication problem.
This is a
That one's a real word. Yay! Then we're going to multiply. Real word.
It's multiply.
Then we are going to properify. Alright, so that's our 5 steps. If I have a division situation and it has fractions involved, I gotta go, okay, improperify, flipify, that makes it a multiplication problem, don't forget that part. Simplify, multiply, improperify. I had a thought, now it's gone. Oh, so last year, someone who likes to come up with mnemonics said, I frequently smell moist pancakes. You can use it if you want. Mashed potatoes works as well, if you prefer mashed potatoes. Alright, for this first one, 1/2 divided by 4, you can take a little bit of a shortcut by making it 4/1 on the original problem. I told you that's okay because you're not clobbering things. People can still see how your work progressed. But now how do I, so that made it improper. I did my first step. So now how do I change this into a multiplication problem? What does it look like after I flipify? Yes, ma'am.
1/2 times 1/4.
So 1/2 times 1/4. Then I simplify. Who can tell me if there's anything I can simplify?
There's not.
There isn't. So I still go through that step. Okay, is there anything I can simplify? So some of these steps don't happen every single time. And then I multiply. What do I get when I multiply? Yes, ma'am.
2 6.
1 times 1/2 times
Oh.
4.
1
2 times 4.
Oh, 1/8.
1/8. She tried to add across the top and add across the bottom, it looks like. 1/8. And then I propify, but I don't need to. So it's a 5-step process where some of the steps don't end up needing to be done. Well, this next one, again, my impropify step, if I have a whole number, I can just throw it over 1. Easy as that. So now on to my flipify step already. Who can tell me what my flipify step looks like? What's my flipify step? What equivalent multiplication problem do I make, sir?
1/1 times 3/2.
9/1 times 3/2. Then I go, gosh darn it, now I can't simplify. So originally, when looking at the 9 and 3, I might have got a little giddy and then realized it's a division problem I can't simplify until I've made it a multiplication problem. So now I cannot simplify. I like to, but I can't. So I multiply. What do I get when I multiply? You end up with 9 times 3/1 times 2.
27/2.
27/2. And then I propify to get what? What's my proper answer, sir?
13
13 1/2. I have these 4 different examples to show you what you need to show. That's why we have these specific examples in our notes. Because this next one, when I do my impropify step, I figure out that 2 2/3 is equivalent to what improper fraction? 2 2/3 is equivalent to what improper fraction? 8/3. And then I go, and then I already have something flippable. So I've done my impropify step, and at the same time, I can switch it to a multiplication problem because that second number is already flippable. So what do I flip it to be? It's going to be 8/3 times what? Yes, ma'am.
6/1.
6/1. So you are allowed to do your first 2 steps together if and only if that second number is already flippable. Is there anything I can simplify before I multiply? We're on the simplify step of our 5-step process.
6 and 3 by 2.
6 and 3 by what?
3.
By 3. She had 2's on a ring because she knew the 6 was going to become a 2. And then I multiply, what do I get? 16/1, but we have acknowledged and said that if I know it's going to be over 1, I can just write the top part.
Oh.
So I can just write 16. If you write 16/1 and then write 16, that's fine too. But you don't have to. That's why in our notes we're showing what you have to show. All right, in the last example, 9/1, but unfortunately, that came out ugly, but also unfortunately, the second number is not flippable. So I cannot flip it until I have shown an equivalent division problem where I have, improper numbers. So what am I going to have as an equivalent division problem where I have improper numbers? Yes, sir?
9/1 divided by 4/3.
Someone looking at your work has to know that you know that 1 1/3 is equivalent to 4/3. They have to be able to follow your logic and follow that step. Now that second number is flippable, so I can make it into what equivalent multiplication problem?
9/1 times 3/4.
9/1 times 3/4. Now I can try to simplify before I multiply. Nothing. So now I multiply, what do I get? Yes, sir.
You get 27 over 4, which is
Da-dee-dee-dee-dee, 27 over 4. So then someone else is going to tell me what it would be when it's made proper. Yes, ma'am.
6 and 3/4.
6 3/4. So that's the type of work that you have to show.